All right, so we're going to start chapter P, section 3, which is all about polynomials and special products. So adding, subtracting, and multiplying polynomials. All right, so now when you're adding and subtracting polynomials, you very simply just want to combine like terms. We did this briefly when we were doing our exponents lesson. Now, like terms have the exact same variables and exact same exponent over those variables. Now, ignoring the coefficient, the terms must be identical. If we do have that our terms are identical, then very simply you just need to add or subtract the coefficients, or just combine them. So something like this, for example, when you look at something like number 1, I have this polynomial plus this polynomial, right? If there is a plus in between, like we see here, very simply all you need to do is combine like terms, right? So just pretend that the parentheses are not there. And if you do, we see that we have a 4y squared and a minus 7y squared. These are our like terms because they have the same variable and the exact same exponent. So all you want to do is combine the coefficients in front. If I combine 4 with a negative 7, that's going to get me a negative 3. And then we keep the variable the same. Same exact thing with our next term, right? If I have a negative 3 and a 9, well, those are both just plain numbers. They don't have any variables attached to them, so all you're going to do is combine them like normal, right? So we're going to do negative 3 plus 9, which is going to get you a positive 6. And that's all we have to do. All right, same exact thing with our next sum, right? So if I have a sum of polynomials, again, you're just going to combine like terms. If I have a 5x to the third and an x to the third, if you don't see a coefficient, you assume it's a 1. Right, so then I'm going to do 5 plus 1, which is 6. Keep the variable and exponent the same. Negative 7x squared, I see another x squared here with a 2. So it's going to be negative 7 plus 2, which is a negative 5x squared. All right, and then I have a negative 3, and I combine that with whatever else doesn't have a variable, right? So that 8. And then if I combine negative 3 plus 8, that's going to get me a positive 5. And then I have an x left over, right? A minus x. All right, now we don't love the way that this is written, right? So if you recall from Algebra 1, we typically want our polynomials written in standard form. Standard form is in order of decreasing exponent, right? So I do have most of it in the right spot. That 3 is the highest exponent, and then after 3 is going to be a 2. But then I always want my constants last. So I want that plus 5 at the very end. So I'm going to write that negative x first, and then that plus 5 at the very end. And I like the way that this is written more. If in the directions of any test or quiz, we don't specify to write in standard form, or if we don't verbally tell you to do so, then you don't have to worry about that. But typically we like our answers in standard form, so this is preferred. Right, this first one is technically not incorrect, but we prefer this. All right, let's try the same thing with the third example, right? Keep in mind this one has a minus in between. When there is a minus in between, what I like to do is I like to turn it into a plus and then change the sign of everything inside of the parentheses, right? So I'm going to turn this x squared into a minus x squared, that minus 2x into a plus 2x, and that plus 1 into a minus 1. And then again, we combine like terms, right? I have a 2x squared minus a 1x squared. That's going to get me an x squared. I have a 1 minus 1. Those are going to go away. They get you 0. And then I have a plus 2x by itself. And then that's all we have to do with that one. More examples, right? This is another difference. I have a minus in front, so all I'm going to do is change that to a plus, and then change the sign of everything on the inside, combining like terms now, right? If I have 7x to the fourth minus 3x to the fourth, that's going to get me a 4x to the fourth. I have a minus x squared plus a 4x squared, that's a minus 1x squared, so that's going to get me 3x squared. I have a minus 4x minus 3x now, it's going to get me a negative 7x. And then I have a plus 2 by itself. And then that's your final answer. All right, number 5, right? We want to do our order of operations first, right? So we see a lot more parentheses and brackets than in previous problems, but I see brackets over a sum of polynomials. So let's try to combine those first before combining anything else, right? So let's see what we get inside the parentheses, or I'm sorry, the brackets. Nothing combines with y squared. I'm going to leave that alone. I have a 3y by itself, and then I have a 1 and a -7. That's going to get me a -6. All right, and then I'm just going to bring everything else down. So I'm going to bring the minus down, and then I'm going to bring the y to the third plus 1 down. And then just like before, that minus is going to turn into a plus, and then change the sign of everything on the inside. All right, and so nothing combines with y to the third. All right, with that negative y squared, that's going to get you a negative y squared. Nothing happens to it. Nothing happens to -3y either. And then I have a +1 plus 6. That's going to get me a +7. All right. Now with multiplying polynomials, you guys probably remember binomials, right? Foiling, first, outer, inner, last. You'll see some other cases. Maybe you just have a monomial. So just one single term multiplying by a polynomial. In that case, you just distribute. And anytime you're multiplying polynomials, you multiply your coefficients and you multiply your variables with their exponents. So you add the exponents if the base is the same. And then after all that, if you have like terms, you would combine them. All right, so let's look at something like this. So I have an x on the outside of this polynomial. If I don't see an operation in between, I assume it's a multiplication. So I can distribute that x to this polynomial. Again, you can use your rules of exponents. This is the same as x to the power of 1. And then if I do x to the power of 1 times 3x to the power of 2, I get 3x to the power of 3. You add your exponents. Same thing over here. I have a minus x to the first. That's going to get me a minus x squared. And then I have a minus x, right? 1 times x is just x. And there's nothing more you can do to that, so you leave it like this. All right, same thing with number 7. I have a -3x on the outside of my parentheses. I don't see an operation, so I assume we're multiplying. -3 times 5 is -15. X times x is x squared. -3 times 2 is -6. And then there's an x that we're still multiplying from that -3x. All right, so that's our final answer. All right, number 8 as well. I have a y squared on the outside of my parentheses. Assume we're multiplying, so this is going to get me 4y to the 4th. Plus 2y to the 3rd minus 3y squared, right? Just distribute that y squared to every single term on the inside of my parentheses. All right. Now, number 9, same exact thing, except our monomial is on the right instead of the left, right? Hopefully you guys agree this is the same as if I had something like this, right? If you want to change the order, that's fine. You don't particularly have to, but sometimes it's easier to think of it like this instead of, going backwards. All right, so let me just write it like this. 2y to the 3rd times 2 is just going to get me a 4y to the 3rd, right? Multiply your coefficients. Minus 2y to the 3rd times -3y is going to get me a -6y to the 4th, right? Multiply your coefficients and then do your y's with the y's. And then add your exponents. All right, so you get something like that. All right, now hopefully examples like these are familiar with us, right? All of these examples are a binomial times a binomial. Now a binomial times a binomial, you just want to FOIL them. So first times the first, so x times x, I'll start with number 10. Outer times the outer, x times 4. Inner times the inner, -8x. Last times the last, -8 times 4 is going to get me a -32. And then you want to combine like terms, right? I have a 4x minus an 8x, that's going to get me a -4x. And then everything else stays the same. All right. Number 11, same exact thing, right? Binomial times a binomial, I could do first times the first. So 15x squared. Outer times the outer, 21x. Inner times the inner, it's going to get me a -10x. And last times the last is going to get me a -14. And then once again, you can combine your like terms. 21x minus 10x is going to get me 11x. And then bring everything else that didn't combine down with it. and then this is your final answer. All right, same thing with number 12. 2x times x, first times first is going to get me a 2x squared. Outer times the outer, 2x times 5 is going to get me a 10x. Inner times the inner is going to get me a negative 4x. And last times the last is going to get me a negative 20. And of course, you can combine your like terms. 10x minus 4x is going to get me a 6x. And then bring everything else down with it. All right, now number 13. Again, foiling first times first is going to get me a 28x squared. Outer times the outer is going to get me a negative 21x. Inner times the inner is going to get me a negative 8x. And last times last is going to get me a positive 6. All right, and then combine your like terms. It's going to get me a negative 29x. And then bring everything else down with it. Right? And that's all you have to do with foiling. Now, if you have a trinomial times a trinomial, we can't really FOIL, but we can still use the same idea of distributing when you have something on the outside of a polynomial. So what I like to do with these is I like to take each term and whatever shows up first and distribute it to my polynomial that you're multiplying with, right? So I'm going to take that x squared and multiply it with this x squared plus 2x plus 2. And then I'm going to take this negative 2x and do the same thing, multiply it with that. So I'm going to do minus 2x times x squared plus 2x plus 2. And then same exact thing with the last term, that positive 2, I'm going to distribute it to this trinomial as well. So I'm going to have a plus 2 times x squared plus 2x plus 2. All right. And then in each of these, I'm just going to distribute whatever term I have in front. So in yellow, I'm going to distribute that x squared, and that's going to get me an x to the 4th plus 2x to the 3rd plus 2x squared. In green, I can distribute negative 2x, and that's going to get me a negative 2x to the 3rd minus 4x squared minus 4x. And I could do the same thing in blue, distribute that 2 on the outside. That's going to get me a plus 2x squared plus 4x plus 4. And then lastly, what we can do is we can combine any like terms. There's nothing to combine with x to the 4th. 2x to the 3rd and 2x to the 3rd cancel out. I have a 2x squared plus 2x squared, which is 4x squared, minus this 4x squared also cancels out. I have a negative 4x and a plus 4x that cancels out. And the only other thing that didn't cancel out was that plus 4. So I have x to the 4th plus 4. All right, and that's the general strategy for doing a trinomial times a trinomial. And this works in any case when you don't have a binomial times a binomial and you can't FOIL it, right? You can do the same exact thing. Even if foiling is a little confusing to you, you can even do this exact same process. All right, so I'm going to do the exact same thing with 15. Take that first term, distribute it to my polynomial. So I'm going to get a 2x squared times x squared plus 3x plus 2. Take my second term, that minus x, distribute it to that polynomial as well. So I'm going to have a minus x times x squared plus 3x plus 2. Same exact thing with our last term, that plus 4. Distribute it to that polynomial. So I'm going to get a plus 4 times an x squared plus 3x plus 2. And then just like before, distribute everything. So in yellow, I'm going to distribute that 2x squared. And I'm going to get a 2x to the 4th plus 6x to the 3rd plus 4x squared. And then I can distribute negative x as well, and then I get negative x to the 3rd minus 3x squared minus 2x. Same exact thing in blue, I can distribute that 4, and then I get a 4x squared plus 12x plus 8. Right, so they get kind of messy, so just be careful with your work. But just like before, you just want to combine like terms from here, right? 2x to the 4th, nothing combines with that. 6x to the third minus x to the third is going to get me a 5x to the third. 4x squared minus 3x squared plus another 4x squared, all right, should get me, what is that, 5x squared? Yeah, plus 5x squared. And then I have a minus 2x plus 12x, that's going to get me a 10x. And then nothing combines with 8. And then that's your final answer. All right, now these are special products that maybe you'll memorize, maybe you won't. One that's helpful to memorize is this first one, right? And you'll see it in the next lesson when we do a difference of perfect squares. This is pretty helpful to memorize. And another case where we recently did this is when we were rationalizing denominators. So let's say I gave you something like 3 minus square root of 5. I had told you guys to multiply by the conjugate, right? Something like that. And then that pattern that I showed you guys, you just square the first minus square the second, right? And that works for any time that you have this exact same pattern, right? If I have two terms, one's a plus, one's a minus, it'll end up looking like this when you FOIL it out and cancel your middle two terms, right? So not a coincidence, it happens every single time. Another thing that happens every single time is when you square a binomial, right? Whether it's a plus b or a minus b. Common mistake that I see, people love to distribute this square and say that this is a squared plus b squared, right? This is not the case. If you need to verify that, write it twice and FOIL it, right? Even if you don't remember this special product that's going to get you a squared plus 2ab plus b squared, you can write it twice and FOIL it, right? There's nothing wrong with doing that. So that's why I say everything from here down, you can choose to memorize it or you can just write it multiple times and FOIL it. Nothing wrong with that. All right, but I'll show you both ways when we get to those. All right, so starting with something like this, you see 2x plus 3 and a 2x minus 3. Same exact terms, 2x and 2x, 3 and a 3, one has a plus, one has a minus, and this is a special product. All you're going to do is square the first minus square the second. So this is going to get me a 4x squared minus 9. Very simple, right? You could FOIL it and do it that way, but we can see that this took less than 10 seconds. Same exact thing with the next one, right? 4a, 4a, 5b, 5b, one has a plus, one has a minus. All you're doing is squaring the first minus squaring the second. And then we get 16a squared minus 25b squared. All right, now when you look at something like number 18, all right, do not distribute that square and say that this is 6x squared minus 5 squared, right? You cannot do that, right? What you can do instead is you can write it twice and FOIL it, right? Let's say I had something like this and I choose to FOIL it. We end up with a 36x squared minus 30x, another minus 30x, and then a plus 25. And then we see that these middle two terms, unlike the difference of squares, do not cancel. You're going to get a negative 60x. All right, and then you can bring down everything else. Right, but we see if you decided to square the first and square the second one, you would miss this middle term and you would get a completely different answer. All right, so don't forget that. Now with 19, let's use the special product, right? So the special product that you saw on the previous slide followed this pattern, right? If there is a minus in between, this is a difference. You can square the first, square the last, and then the middle, it's going to be minus double their product. So minus 2 times 5 times 8x. Now when you go to simplify this, we get 25 minus 2 times 5 is 10 times 8 is 80x. And then plus 8x squared is 64x squared. So we see that if we remember that special product, it saves a little bit of time as opposed to foiling it every single time. All right, but you can choose whichever method works best for you. Even something like this one, 8x plus 3 squared it's the square of a binomial. I'm going to do the special product again. But again, if you prefer to FOIL it, you can choose to do that as well. So it's going to be the square of the first, square of the last. This one has a plus in the middle, so it's going to be a plus double their product. All right, and then when we simplify this, we're going to get a 64x squared. 2 times 8x is 16x. Times 3 is going to get me 48x. And then plus 3 squared is 9. And then that's our final answer. So save us a little bit of time. All right. The cubes as well there's another special product for those. A lot of people choose not to memorize it and choose to write it 3 times and multiply it that way. That's fine. I'll show you both ways. So in this example, I'll just write it 3 times. But you're going to see that it's going to take a lot of work. All right, so let's try this. And we can do one at a time, right? So I'm going to FOIL the first 2. And this is going to get me a 9x squared plus 6x plus 6x plus 4. And so we get a 9x squared plus 12x plus 4. And then I still have another one to multiply. So it's going to be a 3x plus 2. And then just like before, you can choose to distribute each of your terms. This is going to get you a 9x squared times a 3x plus 2 plus a 12x times 3x plus 2 and plus, that's a 4. 4 times 3x plus 2. All right, just like we did before when we did a trinomial times a trinomial. And when we do this, we end up with a 27x to the third plus 18x squared plus 36x squared plus 24x plus 12x plus 8. All right, and then we just want to combine like terms, so we get 27x to the third plus these x squareds are going to combine to get us 54x squared. These are going to combine now to get us 36x. Then we have, whoa, I think I muted myself. Okay, we have a plus 8. All right, so it took a little bit of work. Now I'll show you in number 22, we can choose to remember the special product instead, right? So if it's a cube, and this was also in that page where we had listed our special products, it's going to be a to the third minus 3a squared b plus 3ab squared minus b cubed. Let me separate that. Right, and this is when there's a minus between the two, like there is here. So I'm going to do this instead, and you're going to see that it does save time if you're going to choose to memorize it. If you think that you're going to mess it up and you don't want to memorize it, you can do all of this work here, right? But you're going to see after doing the special product, it's going to save you some time, and you maybe want to, it might be worth it for you to try to memorize this. All right, so I get minus 3x squared times 2 plus 3 times x times 2 squared minus 2 to the third, right? So that's just plugging into this formula here. And then fully simplifying this is going to get us a minus x to the third minus 6x squared plus 2 squared is 4 times 3x is 12x, and then minus 2 to the third is 8. So we saved a lot of time, a lot of space by memorizing this special product. All right, but if you don't want to do that and you want to write it 3 times and multiply it that way, that's fine as well. All right, so let's do a couple more. 3a to the second minus 4b to the second times 3a. I'm going to guess that this is a second. All right, might have been a typo. Plus 4b to the second. All right, this is a minus and a plus, and our terms are exactly the same. So this is a special product. This is going to get us 3a squared minus 4b squared. All right, that's our special product. And so this is going to get us a 9a to the fourth minus 16b to the fourth. That's all we can do there. All right, number 24. All right, take it piece by piece. If you look at these first two, one has a plus, one has a minus. They're the exact same term, so I can square the first minus square the second. And then when I bring down the next factor, we see that it's the exact same thing. X squared, y squared, one has a minus, one has a plus. This is another special product. So this is going to be an x squared minus y squared. So it's going to be an x to the fourth minus y to the fourth, and that's your final answer. All right, last one. Think about the wording of this problem. This says subtract negative 7x to the fourth plus 5x squared minus 1 from 2x to the fourth minus 10x to the third minus 4x. If I'm taking this, right, subtract just means you're taking away. Subtract this from this, that means we have had to have started with this. So I'm going to start with this, right? If I'm taking away from this polynomial, then that means I'm subtracting it. So this is going to be this polynomial first minus negative 7x to the fourth plus 5x squared minus 1. And then this is just a simple difference of a polynomial. I can change that to a plus and then change the sign of everything on the inside. All right, and then combine like terms. 2 plus 7 is 9. X to the fourth. Nothing combines with that minus 10x to the third. Nothing combines with this minus 5x squared. Nothing combines with this minus 4x. And nothing combines with this 1. All right, so this is our final answer. All right, that's it for this lesson. Just multiplying, adding, subtracting polynomials. All right, next lesson will be factoring.